when I'm simplifying radicals, what I'm trying to do is find perfect squares that I can pull out of this, right? Because I know that, for example, if I had the square root of 16, that would just equal the number 4, right? So what I'm trying to do is find these perfect squares that I can pull out of this. So I start by factoring it. Okay, and what I find is that my prime factors look like this. And I'm going to list them all out. And what I do is I pull doubles into their own little house here. Now, why am I doing that? Now look, see, this is a double, right? This is a single. Even though it's the same as this, these are already paired up, and this is also a single. So those stay in the single house. Now, why did I pull the double 2 out? Well, remember, we're looking for perfect squares. This, 2 times 2, that's 4. So the square root of 4, that's 2. Right? So these doubles end up being perfect squares because this is 2 squared, so that's going to make it a perfect square. And then we square root it. So that becomes a 2. Now in here, this doesn't simplify because this is not a perfect square. 2 times 5 is just 10, and that's not a perfect square, and it doesn't simplify. And this is my answer. When I'm solving by elimination, sometimes I have to multiply one of the equations or both of the equations to achieve this beautiful situation here. But for this week, you are just going to be solving where it's already set up for you. What do I mean by it's already set up? This is a positive 4x, and this is a negative 4x. So if I were to add these two equations together, negative 4 plus 4 is just equal to 0x. It's just 0. Do I need to write 0x? No, I don't. Okay. This is 5y minus 2y. These are also like terms. 5y minus 2y is 3y. And these are like terms, right? They have no variable on them. They're both constants. I have more negatives than positives. And 28 minus 16 is 12. I'm solving. I'm getting y by itself. Okay, now, here's the thing. I'm not done, right? Remember, my answer, my solution to a system is an x and a y. So far, I only have a y value. I'm going to plug this back in and find my x value. Okay, so it doesn't matter which equation I plug into, but I'm going to plug in to find my x. So I'm going to just plug into this one. 4x minus 2y equals 16. So this becomes negative 2 times negative 4 is positive 8. And I got x by itself, and x is 2. And that's my answer. Okay. If you want to check it, what you can do is just take this 2 and negative 4. Watch, I'm going to just do it in my head. Let's say that this was a 2. Look, I'm doing the other equation, so I use this bottom equation to plug in. But let's say I just plug back in. So that's negative 4 times 2, that's negative 8. 5 times negative 4, that's negative 20. Negative 8 plus negative 20 is negative 28. Yep, cool. All right, solve by factoring. I'm looking for two numbers that multiply to this and add to this. Okay, and I'm setting it up like this. Now, I notice right away, right, that this was just x squared. So this is x, right? And I just need the two numbers that multiply to this and add to this, and that's all I'm thinking about. So when I'm multiplying to a negative number, I know one of my numbers is going to be negative, one of them is going to be positive. My numbers that add to 70, the one that comes to mind right away is 10 times 7, right? But there's other possibilities. There's 14 times 5 and 70 times 1 and 35 times 2 and 5 times, oh, I already got 5 times 14, right? So there's other possibilities, but I need the ones that, now remember, because one's going to be positive and one's going to be negative, they need to subtract to 3. So which pair subtracts to 3 is this one, 10 and 7. And I want them to subtract to negative 3, so I need there to be more negatives than positives. So I'm going to make the 10 negative and the 7 positive. So negative 10 times positive 7 is negative 70. Negative 10 plus 7 is negative 3. Now that's factoring, but I'm not quite done because it says solve by factoring. And I see that this times this equals 0. So that means either, right, if this times this equals 0, then either this must equal 0 or this must equal 0. And so that looks like this. So x could possibly equal 10, that's one possibility. Or x could possibly equal negative 7, that's another possibility.